Good afternoon, everyone. Welcome to another live session at the Reactor. My name is Rav, and I'm the program manager here at Reactor London. Before we get into the session, please take a moment to read our code of conduct. We're all here to learn, so please be respectful, please be kind, ask a lot of good questions. We're all here to learn. Today, we are here with Marco, who's going to talk about Azure OpenAI for the ASP.NET Core developer. And with that, I'm now going to hand it over to him. Hi, Marco.
Hello, everyone. Thanks very much for joining us today at this session. I promise you it will be amazing because we're going to talk about an amazing technology, which is large language models, what we can build with them, and what kind of user experience they unleash for our applications. So my name is Marco. I work for a company called Mondra, where we've been adopting OpenAI in our product for several months now. So we can consider ourselves some like early adopters, I would say, of the technology. But before we start, let me just add a little bit of a disclaimer here. So I'm not a data scientist. So if you expect lots of data science, mathematics, etc., in this talk, you might be a little bit disappointed, right? There will be some data science concepts, right? But most importantly, this is going to be how, as an ASP.NET Core developer, as a web developer, how can I adopt OpenAI? How can I make my applications different from before? So that's why I think it's really exciting, because the technology per se is just incredible what we can do with it. So why is it so cool? But basically because it allows us to design a new user experience for our web applications, right? Which are not just limited to chatbots and things like that. And we will see some examples during the talk, right? But it's definitely a new way to interact with our data, with our services, etc. And we're going to see some of these things, right? We're going to see how our models can interact with the services that our application is exposing, how we can, for example, solve, I would say, a problem that for me as a developer has been really mental until this technology came out, right? How do we handle non-structured data input? So, for example, if we have a contract, right, a big text of a contract, and we need to understand who are the parties of the contract, so what are the terms of payment, right? So all these things were just so difficult to do before large language models became a thing, right? And we obviously also will have a look at some data as well, right? Some data integration as well, not just around the searching of data, but I want to show you an approach, if we have enough time, on how to also analyze our data sources. So, for example, if you have a SQL table with your data, what can large language models do with it? Okay. Before we get started, though, I just want to point out. So when I first started working with these technologies, I was a little bit confused on what is the difference between OpenAI or Azure OpenAI, right? Which one I should adopt? And the answer is pretty simple. They're pretty much the same thing, right? So the technology is the same. Pretty much all the demos that you will see during today's talk will work in both in both services, right? I would say that Azure OpenAI is a little bit slower to roll out the new functionalities as they become available. So they become available first in OpenAI, and then usually a bunch of days afterwards they are also available in Azure. From the Azure perspective, I think that the major key points are that the whole service is integrating with the rest of the Azure ecosystem. So, for example, you can use Azure Active Directory and manage the entities, for example, to log in to acquire a token valid for your chat endpoint, for example. And also from the billing perspective, it's quite useful because it's quite important that the fact that you still have Azure as a service provider. So if you have, for example, an MCA agreement with Microsoft, etc., right, all of the spend for OpenAI comes from the Azure bill, right? In case you're using Azure OpenAI. But apart from that, they're pretty much the same thing. There are some differences in terms of data privacy and residencies. For example, in Azure, you can decide that you want to spin up a server in the EMEA or UK territory, right? You don't have this capability in OpenAI, but functionally speaking, again, it's exactly the same thing, right? So I've talked already too much on slides. For whoever ever seen a talk from me, I usually tended to stick to Visual Studio a lot, so it's already beyond my usual timing. So let's head to Visual Studio and see what I got for you guys. So the first thing is going to be explaining a little bit how we interact with these models. And in order to do that, I have created a relatively simple application here, right? Which is, for now, I promise I will make it prettier later, but for now, it's just a simple bot, right? To which I can ask things such as, I don't know, tell me 5 ways to cook mushrooms, for example. And as soon as I hit enter, this is going to query the model, right, and give me the response. Which model am I using here, right? So in this case, I'm using Azure OpenAI. So in my resource group here, I have created a few instances of the Azure OpenAI service, right? These are from different regions, simply because not all the regions have all the models, right? So you need to switch between one or the other in order to have for example, the most recent models, right? And in the case of today specifically, I'm using this East US 2 region where the newest GPT-4o model is available. So all the demos of today will be powered by the newest GPT-4o model, which literally came out a couple of weeks ago. Okay, so as you can see now, the model has responded to me with a bunch of trick recipes on how to cook mushrooms. Let me zoom this out a little bit. And as you know, this is a contextual chat. So at this point, without giving any other context, I can say something like, tell me more about option 3, for example, right? And the model will think about it for a second and then respond me to what is the option 3, which in this case is grilling. Okay, it's going to think about it for a little while. But how does it work? How does it work under the hood? So how can the model keep the context? Yeah, here you go. We got the grilled mushrooms. How does it work under the hood? Well, basically, the context is preserved thanks to a history of the chat, right? Which is made of an array of messages, basically. Okay, the first message is what we call the system message, the one that sets the context to the bot. So in this case, it's very simple. You are a very useful AI who will answer question, right? But here you can set whichever context you want. You can say you speak in rhymes like Shakespeare or things like that, right? And then there's an alternation of user and assistant messages, right? Like in this way. And every time I want to send a new message like this one, right? I usually want to send the entire history so that the model will process it as in its entirety, right? And will understand the context of my very vague question here, okay? How does it work then in code, right? So this application is well, forget the UI. The UI is really not that important today, but it's working with a RESTful endpoint that I have created in my web API called chat controller, where I'm keeping, first and foremost, a collection of all my sessions. And a session for me at the minute is what I call here a chat history. Is implemented by this class, right? Which for now is just basically a collection of chat request message. Okay. And then I have my endpoint here, right? A post endpoint. Let me just close this to make it more readable. A post endpoint, which I called message, where is basically the chat. The chat in the UI is posting the new question from the user. right? And what do I do with that? Well, after having retrieved the history, what I'm doing here is that I'm creating a new instance of a class called OpenAI client, which comes with the Azure SDK, right? Where I'm specifying the endpoint I want to use and the credentials that I want to use. In this case, I'm just using the Azure key credentials, so just the key that comes from the portal, right? But normally you can use also, as I said, Azure Active Directory to log in at this point. And then what I'm doing is that I'm adding the new message of the user to the existing history. And then I'm calling this method here, get chat completions async, right? And this method will accept the entire history of messages plus a bunch of other parameters. I'm sure you can find lots of documentation about those. But for example, the temperature is something that affects the variability of the response from the bot, right? And after this call is completed, what I get back is a response, which contains a collection of choices, right? This collection of choices usually has only one single element, which is just the single response from the model. You can request potentially more responses if, for example, your use cases require that. And this choice, right, contains the message that the bot has elaborated to return to the user. Okay, so I get my response message. This is the text of the recipe for the mushrooms, for example. And then what I'm doing is that I'm adding this response content to the history, as you can see, right, so that it can be retained for the future queries, right? And then I'm just simply returning it to the user. Okay, simple enough. The problem with this approach is that I don't know if you noticed it when I was doing the demo, but the interface is works a little bit differently than, for example, what we are accustomed to with ChatGPT, because we have to wait for the model to generate the entire response before we can see anything appearing here on the screen. All right, and this is because what we're using is what is called the synchronous endpoint. Right, there is a second endpoint, which is the streaming endpoint, right? Which I've also implemented here, right? And provides a way better experience to the user. Okay, let's see it in action first and see what happens, right? So I need to change the client code in order to be able to call the. So let me comment this out, and I want to enable the call to the streaming endpoint. We're going to look at the code in a second, right? But right now, if I just do this trick here, and we wait for the application to compile and reload, let's see what happens. All right, I'm asking the same question as before. Tell me 5 ways to cook mushrooms. And in this case, as you can see, this the response is composing as the model is generating it. Okay, so how does this endpoint, the second endpoint, work? So let's have a quick look to Chat Controller again, and let's start by saying that the first thing that we need to do for a streaming endpoint is to use a streaming endpoint is creating an action in Web API which returns an async enumerable of string. So this is because ASP.NET Core supports natively this concept of streaming responses. All you need to do is, again, just having the proper return type. All right. The input is pretty much the same. I'm just accepting the initial message from the user, right? And then what I'm doing after creating the client, the client to OpenAI, and adding my message to the history, exactly as I was doing before, I'm calling this slightly different method in my client called get chat completions streaming async. Okay. Parameters are pretty much the same, right? But the response is a little bit different. So if we have a look at the type of this response, right? This is a streaming response of T, it's a generic type, which also implements async enumerable. Okay, So an async enumerable, guys, for those of you who are not accustomed to it, is something that I can iterate with an await for each. And this is exactly what I'm doing here, right? I'm doing an await for each of all the individual items contained in that response, right? Which are chunks of the response message, right? And for each of these chunks, right, what I'm doing is that I'm returning the token, the part of the response to the client so that the client can display it, right? And if we look at the log here in the application, as you can see all these individual tokens that I've returned to the client, right? But also I'm concatenating all the responses so that as soon as I have the full response, right, I'm just adding to the history exactly like I was doing before. Okay, so that we can keep also that in our sort of archive, and we can send it over again when the client asks for other things. Okay, so this is quite similar to the other one, apart from this await for each. On the client side, if you're using Blazor, this might be relevant to you. So what I've changed is that in my send message async, I'm posting the new message to this endpoint that we just discussed, right? And I'm using this post and get stream async method, extension method that I have created, right? I will not just digress over how it's implemented. Go and have a look at the code by yourselves if you're interested on it, or just copy it and use it for your applications. No worries. The only thing that is worth mentioning is that this post and get stream async also on the client side returns an async enumerable of string, right? And so also on the client side, what I can do is just doing an await for each of all these items, and for each of these items, I'm just appending the content of them to the chat, right? And we get this nice experience that we have just seen in action here. Okay, so we've already done something to improve the user experience. Now, this is not really like production ready yet, right? For a number of other issues, and the main one is our handling of the chat history, because this chat history at the minute will keep growing indefinitely, right? Until at some point it will explode, right? Because we have nothing to cut it down. And what is the implication of that? Where the responses will get slower and slower simply because we're sending a bigger payload to the model, and therefore the model will have more data to process before coming up with a response. We're going to pay more money, right? Because we pay based on the number of tokens we send to the model, right? And this means that bigger histories equal to more fees for our OpenAI service. And the third thing is that eventually, even if, for example, GPT-4o has a payload, which I think as a maximum size is 128,000 tokens, right? Which is kind of a humongous size, right? But it's not infinite, right? So eventually, if we keep appending things to a chat, right, the model might just say, yeah, no, that's too much of a payload for me. I can't process it. Okay. So how do we deal with that? Well, there are a few approaches, right, to deal with controlling the size of the chat history. The simplest one is, let me go to my chat history definition here, which is here in chat controller, and here. The simplest one is something like the one that I have here prepared for you, in which I'm setting a token limit, right? And the idea is that if the chat becomes longer than this limit, I just start truncating the items on the top. Okay, it seems a really basic approach, right? But it's actually very very effective, right? Because what we've seen even in production scenarios is that the flow of the context of the chat naturally flows with the chat itself, right? So if this limit is sufficiently high, right, you will not notice any issues whatsoever with the model not remembering the oldest messages. But if the user refer to some very old message, right, what could happen is that the model might be confused and ask for a question, which is really no harm. But let's see in code, how do we do that, right? So I've set this token limit here, and what I'm doing is that when I'm adding a new message here, I'm calculating the length of the total history. Okay, and in order to calculate that, I use this formula, right? I will not I would just skip the explanation, but I've left you a link that you can go and read with all the meaning of these things, right? I just wanted to mention that in order to calculate the tokens, the number of tokens, I'm using a library called the sharp token, right? Which implements this entire logic. I'm just saying, yeah, you need to use the GPT-4 tokens, right? But basically, when we have a total length which is higher than the token limit, I just start removing messages until I'm within the limit. But notice that I'm doing that from from the second one, right? So I always keep the context message, the system message on the top present in my history, because that is required. Okay. And this is basically the logic. Now, in this example, I'm keeping it incredibly low, right? Typically, I would do 7,000 here or something like that, right? 700 is really low amount, but just wanted to show you what is the impact of the model forgetting what was the context of the conversation. So if I rerun the application now once again, and I ask the usual question, tell me 5 ways to cook mushrooms, right? The model will respond here, and let's wait for the response to be completed. Here you go. Now, if we look at the log here and we scroll all the way to the bottom, now we are at 414 tokens, right? So let's add another question. Tell me more about option 3, for example, right? And the model should respond about roasting mushrooms. Here's here are the instructions, etc. Blah 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 blah. And as soon as this is done, okay, serving tips, etc. Yeah, this is incomplete because I set the maximum limit of 500 tokens for the response. Now, if we look at the log again, right, as you can see, we have overflown the history, right? So the system has now removed my 2 old messages, right? So tell me 5 ways to cook mushrooms, for example. So now at this point, if I ask the model what was my original question, right, the model will not know what was that question, right? So this is the implication. But again, if the number of tokens is sufficiently high, your user will pretty much never incur in something like that. We have some other approaches we can use to deal with the chat history, though, right? So, for example, I wanted to show you is something slightly different, right? Like this one. Let me just discard the changes here, right? Yes, let's discard the changes. And let me just set it to 700 here as well. So in this case, what I've done is I've created another version of the chat history called the summarized chat history, okay, which inherits from the previous one. But what I'm doing is that when I'm overflowing here, instead of removing the old messages, right, I'm starting a background task, right, to ask the model to summarize the current content of the history so far, right? So I'm saying something like, I'm going to provide you a JSON representation of a chat conversation, create a short summary of the entire content, and blah 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 blah. okay? And it's basically sending this queue to the model, and at the end of when the response comes, right? What I'm doing is that I'm creating a new chat history, right, which contains the original prompt plus a recap of the conversation so far. Okay, let's see how this works in action, right? So let me rerun this application here. And I've seen that there is a question already about how can I connect an external API with the chat that you created. That is going to be the next topic. So bear with me, and I will respond to that question very soon. Okay, so let's go now to the chat history. Usual question: tell me 5 ways to cook mushrooms. Get the response. In the meantime, tell me more about option 2. As soon as this is done. There you go. Now option 2 is on the go. And as soon as this is done, we should be able to see what happens with this compressed history now. All right, so let's go to the log here and see what the model is generating. Overflow detected, compressing history, because now we are at 1,000 tokens. And this is now the new history, which contains a summary of the past conversation, right? So now this is my entire history right now. So I'm starting pretty much brand new. But the difference from before is that if I now ask, what was my original question, right? The model should be able to recognize that the original question was asking 5 ways to cook mushrooms. Okay, so this is another approach that you could use if you reckon that you want to keep perhaps your history is a little bit more compressed, and you still want to keep the context of the past conversations. Okay. The last thing I wanted to show you before talking about the integration with other services, right, is so since now I'm using GPT-4o, which, as we know, is multimodal, right? So allows me to interact not only with text but also with other means like images, for example. I wanted to show how this actually works, right? So I've created in this other demo a slightly different version of this chat, in which as soon as this refreshes, what I have is this little button here to add some attachments, right? And in my case, I want to add a few pictures, right? And what the code is doing, we're going to see that in the code in a moment. But what the code is doing now is basically uploading these files into the blob storage, right? Yeah, as you can see, I've just sent these messages, and now I'm going to ask, okay, what can tell me a recipe for these ingredients, and the model will consume these images as well as my text and provide with a response. Okay, we're going to look at the response in a second. Yeah, but as you can see already, it has understood that we're talking about ham, egg, mushrooms, etc. Right? So how is this done in my code? Right. So let's have a look at the UI first. Right. In the UI, what I'm doing is that let me just grab the request. Yeah, here you go. Send message async. What I'm doing is that I'm sending an array of strings to my message stream, right? And this array of strings contains, as a first thing, the message of the user. Okay, so the new message entered by the user. Okay, so this is my text, right? And then I'm also adding a sequence of URLs as a follow-up, right? So it's an array of, in my case, we're 4 images, so it's an array of 5 strings the first one is my text for the request, and the following 4 are just URLs, okay, of those images in the blob storage. And in my backend now, in my chat controller, what I'm doing this time is that I'm creating, and I need to go to the streaming message. I'm creating this new type of object, which is a list of a chat message content item. Okay, so this is a sort of a message that contains multiple different content parts. Okay, now the first part of this content is going to be of a text type, as you can see, right? And it's going to contain the first string in the payload, which is the text of that the user has entered. Okay, and then for each of the following elements in the array, which are the image URLs, I'm going to add a payload. Okay, sorry, I'm going to add a chat message image content item, which contains the URL of that image. Okay, and amazingly, it's just that. Then the flow is exactly the same as before. I'm adding this composite message now to the history, and the model will be able to process it in the way that we've seen. Okay, so this is also I think it was interesting to show how we can leverage multiple types of content, right, in the context of the same request, and have the model still being responsive and understanding what we're talking about here, like in this example. Okay, cool. Now let's go back to the slides one sec, because so far I think we've achieved already quite a lot, right? We built a fully working chatbot, but the problem is that at the minute we can only query the bot for its knowledge, right? The bot has no understanding whatsoever of the outside world, or what it can't really do anything, right? And this is the next barrier we're going to break, right? Thanks to the introduction of tools. They were called functions in the previous versions of GPT. Now they're called the tools. But what are tools, basically? So think about tools from the technical perspective, like a fine-tuned version of GPT, right? Which can accept a system message, which is a little bit more complex than the one that we used before. So I can send something like that, right? You are an AI which can provide useful information for the user, blah, 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 blah. But also you can attach manifests of functions that the model can leverage to better craft a response to the user. So for example, one of these functions could be get weather, right? So where we describe what it does, and saying that this function allows you to request a weather forecast for a given location. Okay, and how does the flow works when we have these things, these functions available? So let's assume that as a user, I'm requesting something like, well, I need an umbrella for tomorrow in London, right? And as we've seen, what we're doing is that we're sending that request to the GPT API. Now, here's the thing. The GPT API could understand that it needs to call a certain specific function to answer that request, and send me a special response called tool calls, right? In which it says, yeah, you need to call the get weather function, passing London as a parameter. So let's first demystify then the fact that the model per se is not calling anything, right? We don't have to grant any access to the model to our functions, right? It's just the model. The only thing that the model does is giving me an instruction to call a certain functionality, a certain tool with some parameters. Okay. Then what I need to do as an ASP.NET Core developer is calling the weather API, passing the right parameters, and this weather API will respond in a certain way, and I need to add the response to the history, right? Then I'm going to call the GPT API again, right? Passing this new history, and then the model will say, hold on a sec, I need to call now shopping add function, passing umbrella +1, because the API has said that it's going to be raining in London, right? And so again, it's my responsibility to call the shopping API. We will add the result of that API call to the history, call the model again, right? And finally, the model at this point will say, yeah, it's going to rain. I bought you one umbrella for tomorrow in London. Okay, cool. So let's see this in action here. And I need to switch to another branch here, functions. And let's see what we got. So what I have is I have created here in the solution this interface here called the iFunction adapter, right? Which contains basically exposes, a few things such as the function name, a function definition, right, and a method to invoke that function itself. Okay, and for example, yeah, I have created a weather function adapter that is called getWeather, right? And with this method, this is where we return the manifest of the function. This is probably the single most important bit of the function, right? Typically, description, things like that don't matter, but they really do matter when we're talking with a large language model. Because, for example, here we need to specify what the function does, right? So what is the description? And this is what will trigger the model to call that function in case it's needed, right? So, for example, gets the weather forecast for a given city for the specified dates, right? And we can also specify the parameters for that function, right? So we can say that, for example, we have a parameter called the location that contains the city and the state, for example, San Francisco, California. We have a start date and an end date, right? And also, all these parameters need to be properly described, right? So, for example, during my initial tests of this, I was using use the ISO format, but actually I felt that sometimes the model wasn't getting the format right. So I preferred having an explicit format here for this parameter like this one, and even adding an example of how that parameter would look like. Okay. Once we've done this definition, so in my code here, I'm adding a few functions to my IOC container. And if we go and now have a look at the chat controller, right? What I'm doing, let's look at the synchronous endpoint because it's a little bit more simple. We've seen that the streaming endpoint is just a bunch of async for each, right? So probably here it would be more clear to explain how the function loop works, right? But basically what I'm doing is that in my usual post message here, I'm creating my options to call my get chat completion async, right? And in my options, I'm basically adding the history of the messages and also all the function definitions that I have defined in my application, right? So there would be get weather plus other function definitions that I have created. Okay, and once I do that and I call the get chat completion async, right, and I get the response as before, the choice, right? There are a couple of things that could happen. The first thing is that the choice could have a content. So the model has responded. So this is pretty much the case of before when we didn't have functions. And the code will be shared. It's available in GitHub for you to have a look at it with more time once the talk is finished. So if there is a content, I'm just basically appending it to my response and will be sent back to the client in this synchronous message. Okay. But the other thing I could change is that I could get these tool calls, right? So this is a collection, right, of calls that the model has requested for me, right? And there could be more calls, right, in the same go, right? And if there are any tool calls that I need to do, right, what I'm doing is that I'm appending this request to the history. We need to be keeping tracking also of the request for these tools so that the model knows that it has requested the weather in London, and later on would get also the response for the weather in London. And for each of the tool calls requested, right, I'm calling this method here that I created that is basically executing the call, right? And when I execute the call, right, I use this parameter here. I pass this entire parameter to call, and this parameter contains the ID of the call, the name of the function we want the model wants us to call. So, for example, get weather, and also the arguments the model wants us to call that function with. Okay. So, for example, London and the date of tomorrow, 6th of June, 2024. Okay. Now, on these arguments, there's one important disclaimer that is here in the documentation. So let's go and have a look at it. Go to definition. Right. So this is super important. So these are the arguments in JSON that the model will generate for us, but it's not always going to be a valid JSON. So this is something that we need to take into account. So the model might hallucinate parameters that don't exist, right? Use the wrong format, etc. So your code that treats those parameters will need to be aware of that and defensive for these things. Okay. So for example, if we go and have a look at my weather function, okay, what I've done in my execute async, so I get these parameters and I try as a first thing to deserialize them into an object, which is the weather query object, okay? But if at any point this deserialization fails, because for example, the format is not valid, etc., right? What I'm doing is that I'm returning a message to the model saying, I could not get the weather, check if the parameters are correct, right? And the model most likely will interpret this response, right? And the next time attempt another call with the right parameters. So it's important to, it seems bizarre to say, but talk to your model, right, in the most explicative way so that the model can understand its errors, right, and correct them, okay? If instead the parameters are correct, what I'm doing is just generating the usual random weather forecast, right? Right. So what I do after that, right? I get that response and I add that response to the history, right, as explained, so that the model knows of the weather in London and all the other things. And then I'm looping this entire thing, right, until I have a finished reason saying stop, right? So what does it mean? It means that if we recall what I said in the slides, right? Let me just refresh those, right? I'm doing this loop here, right? This one, passing every time the new responses of the model, so until the model says, yeah, I can elaborate a proper response for you, and then at this point the request is stopped. Okay. So let's see all of that in action. And since I think we're running a little bit short on time, let me show you. Let's do a first example first, and then I'll show you also a more complex type of approach to this. Okay, so this is starting, and now if I go to my chat here, let me refresh this. All right, now I can say something like, what's the weather tomorrow in LA, London, and New York, for example. Right, so I'm asking this question. And if we look at the log here, let's see what happens. So as you can see, the model is now saying, I need to make 3 calls, right? 3 function calls. And we can make these calls even in parallel because the model understands that these are independent from each other, right? It doesn't need the response of these calls in order to understand what the next call is. So the weather in Los Angeles do not affect the weather in London, obviously, right? And it's passing me all the parameters, right, as expected with the dates, etc., right? And I'm returning, I'm appending all these responses to my chat history, right? And then eventually, when I send back to the model all these responses, the model will say, yeah, this is the content for my response. Here it is. And the response has stopped. And therefore, there's nothing else to process anymore. Okay. Rav, how long do we have again? Do we have another 10 minutes?
Yes, we have about 15 minutes.
15 minutes. Amazing. So I can show you a bunch of other things. Okay, amazing. So we've seen, so functions can be really, really powerful, but the really important thing about functions is that they really enable a number of scenarios which might not even be that obvious, right? So I encourage you to think a little bit out of the box on how to use them. So let me give you an example of that. So let's go back to the slides one sec. And let me move to the next slide. And let's talk about the problem of data inference, right? So what is data inference? So think it's basically getting data which is non-structured and transforming it in structured data, okay? So for example, I have I don't know, a review of a hotel, right? And I want to transform that into some, create a class out of it that contains very specific data, like the name of the hotel, duration, etc. Okay? So I could do that just by using my chat interface, right? So I could say, you are an AI which can infer information from a hotel review. The properties are exactly yada, yada, yada. Also return a JSON response, okay? But I don't know if you guys have tried that, right? But this is really complicated. It's more complicated than it should be, right? Because sometimes the model will respond with something like, yeah, here's your JSON, right? And it just ruins your completely your deserialization logic, right? So we need to have some prompt engineering skills to create the right prompt here. We need to be defensive against the prompt injection attacks. Again, risk of malformed responses, etc. Right? For me, a really nice way to solve the problem of data inference is by using tools, right? So the same technology that we use to get the weather forecast. And how would you do that? So let's move to this branch here. So let's assume that, and I'm gonna compile this first so that we don't have to wait. So what I've done here is that I have created this object here, review details, okay? And this object contains hotel name, duration, sentiment value of the user, positive and negative, and aspects, and also, oh, sorry, this is just it's slow and refreshing. And also a customer type, which is an enum that says a single copy, family, business, etc. Okay, and then I have created a special function, which is this one, which I've called the review inference provider, right? Here's my name of the function, hotel review. This function is used to store details of a review. Positive and negative notes must be in English. Yeah, must be in English and must have at most 3 elements each. Okay, and then what I've done here is describing as parameters exactly the object that you've seen before, right? The hotel review. So hotel name, duration, customer type, which is an enum. These are the possible values, etc., etc., etc. Okay. And then I have created this separate controller, inference controller. Okay. And this controller has this action, infer reviews async. Now, this action here returns an instance of a review details, right? So it returns effectively an instance of my object, right? It's not really evident because of the task of iAction result, okay? And how am I doing this, right? So I'm firstly giving a little bit of context to the model, right? So you are an AI which helps storing review data. You will be prompted with a review text between triple backticks. For example, prompt could be like Hotel Corinthia was simply stunning, right? And you need to invoke hotel review to store the review details. And so I'm tricking the model in thinking that it needs to call that function, right? And also the other thing I'm doing is that when I'm passing my function definitions, right, and this contains only, in this case, it only contains the hotel review function, I'm also passing this additional parameter called tool choice. Now, this parameter typically is set to auto. So we let the model decide which function it needs to call. But in this case, I'm setting it to the same function definition which we've seen before, right? This one of the hotel reviews, so that the model will be forced to call that hotel review, okay? And if we go and look at my code here in the controller, right, after sending the request to the model with the content of that review, right, all I'm doing is that I'm expecting to find a tool call, so a request for the model to call that particular function. And in that tool call, right, my behavior is to just deserialize the response. So I'm basically using this trick to get a JSON, a valid JSON that represents my review, and I just need to deserialize it into a review details, right? And this is then this review details is exactly what I'm returning to the client, right? So let's see all of that in action. And let me launch the application. And here in my code, I have a bunch of hotel reviews, which I've created. So for example, I don't know, let's use this one, okay, which is in English, right? And if I look at the code, I go to my inference model, I call this, right? And now this is calling my endpoint, and as you can see, it's saying, yeah, this is the Rembrandt, duration 2 days, sentiment value 0.6, business, positive notes and negative notes. And the interesting thing is that it also works for any language. So for example, this one is in Swedish, right? I don't know how many of you guys can understand Swedish, but basically, yeah, here you go. Rembrandt, 4 days, customer type, family, positive notes and negative notes. Please note that even though I've instructed the model to only use give me 3 positive and 3 negatives, the model has in this case mistakenly added 5 positive notes, right? So we need again to be defensive in our code and just make sure that we can account for potential mistakes that the model might make. Okay. The other thing I wanted to show you is so to recap on functions, right? So they can be useful for several goals, right? Let's think out of the box on how to use them. They might require a little bit of prompt engineering skills, right? Because we need to test and make sure that the model can understand properly how the parameters are formed, etc. No guarantees though that these parameters will be correct. So always validate and perhaps respond to the model with an explicit error so that the model will understand what it has done wrong, right? And just one last thing, remember that they are part of the context that we send to the model. So they use the tokens in the prompt. So my suggestion is, I mean, the model, if you just stick 50 functions to the model might get confused. So what you want in this case is to have an approach of having, I don't know, 7, 8, 10 maximum functions, right? And then perhaps understand if you want to expose more than that, understand from the intentions of the user which area, I don't know, billing or customer care, etc., they want to access, right? And expose a subset of the functions that matter for that particular area of your services. Okay, right. Wow, it's 5 minutes left. I wanted to talk about data a little bit. Now, there's an interesting example of what to do with functions, which is integrating with data search, etc. I'm just going to show you the result of that, and then you will be able to look at this in the code. But basically, if we implement a proper flow, right, what you can do is that you can, for example, send a flow like this one, and so I'm going to London tomorrow from Italy for a couple of days with my wife. Please check the weather and add to my shopping list anything I need. Also book a romantic hotel for the two of us close to restaurants. Okay, so a very complex request. And I've exposed a bunch of functions here to check the weather, to manage a shopping list, to search a database of hotel reviews, and get back, to search, to do a semantic search over this database of hotel reviews, and also to do a fake booking of the hotel, right? And if we look at what the model does with this response, right, as you can see, the first thing that it does is doing a get weather and a hotel search with a romantic hotel in London near restaurants, right? It's going to get some responses here for both of these things. And then if we keep looking, okay, these are the responses. It has added one umbrella to the shopping list, right? Because the first response to the get weather was saying probably partially cloudy, so perhaps he's concerned that I might get wet. So it has added this umbrella and light jackets because the temperature is nice. And then eventually it has called the hotel book, passing the argument, hotel name, Apex, London Wall, check-in date, check-out date, number of people, etc. Got a confirmation back, and yeah, just said that. So I think this is a very good result, right? And again, you can keep chatting. So for example, ask what is my confirmation number, and the model will remember that the confirmation number from this past call was ABC123 and just return it to me. Okay, so I think it's a really powerful type of engagement that you can provide to your clients. The last thing I wanted to show you guys is something slightly different though. So we always see demos about doing searches on data sources, etc. But how can we approach something like data analysis? So what if instead what I have is I don't know, a table in my database with 7 million rows, right? And I want the model to get some sense out of it. And in order to demonstrate that, I have created this other page for the data analysis, where in my case, I can upload any given file. So let me just pick one. So for example, I love playing golf, right? So I have a file with some statistics of the PGA Tour, right? And again, no matter how big that is. And let's see what my code has, right, in this analysis controller. So let's go back 1 second to the code base here. And I have created a couple of functions, right, which are, well, the first one is this CSV get columns adapter. Okay, so this function here allows you to return the column names and their types to of a certain type, of a certain file. Okay, and accept the file name as a parameter, right? And what I'm doing here is that I'm uploading my file to a data lake in Azure, and then I'm using Azure Synapse to read that file from the data lake, and I'm calling this SP describe first result set of the Azure Synapse, this store procedure that will eventually tell me, if we look at the log, that these are the columns in that file with the type float or whatever, right? Okay, for each of the columns. And then I've asked the model, if we look at the analysis controller, to you are an AI expert of data analysis. So after reading the schema, you need to determine 3 insights or comments you would like to retrieve from the data, right? Generate then the corresponding SQL query and I've exposed another function to run that query called the query file and interpret the results, right? So let's look at this second function, query file, how it's made. So there's this CSV query adapter, query file, and this basically requires the file name and the SQL query that the model wants to run, right? And again, this is a run over a SQL Server-like engine. So I'm saying you always need to make sure that the code is a standard T-SQL and blah, 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 right? And then eventually what I do in the function execution is that I just run the query that the model has generated for me, right? In Azure Synapse so that I can read the CSV file directly, right? But obviously, if you had the data in SQL Server, you could just query SQL Server, right? So I'm creating the connection, executing the query. Now, here's the thing. I said that to the model to always limit the number of rows, right? But there's no guarantee that it will get it right. So I don't want my application to explode fetching 3 billion rows from a CSV file. So here, for example, I'm enforcing that I always get maximum 20 rows, right? Regardless of what the model says. It might be that the model doesn't get the right T-SQL, right? So I want to be defensive on that. And if the query generates a SQL exception, I'm returning it to the model so that the model can understand what it has done wrong, right? And eventually, again, if we look at the log, right? So the model here is asking for 3 queries like this ones, right? And my Synapse is responding with all these things, right? All these responses. And what I get out of it, if we look at the chat, is something like that, which I think it's really, if you think about it, it's really mind-blowing, right? So top players by speed and distance, player, blah, blah, blah. And you can literally chat with your data in your database. So you can ask things such as, is there a correlation between driving distance and the number of birdies, right? And you ask that question, the model will just trigger. Let's move it down here. Yeah, you see, will generate a query for driving distance and total birdies, right? And eventually, once it gets the response from Synapse, will or from your database, will elaborate that response, right? And will tell me something about it, right? So, for example, I don't know if there is a correlation or not. But it appears to be a positive correlation between driving distance and the number of birdies, right? So I think that this is a really powerful way of working with your data and a GPT model. I think the time is up. Correct me if I'm wrong, Rav, but I think that we even overrun by a few minutes.
Yes, yeah.
Sorry about that.
Yeah, no worries.
So let me just conclude with what we've seen. So we got accustomed with the chat completion API, talked about even complex function integrations. We've seen how we can use functions for data inference. We didn't talk about embeddings and vector search, but there are demos. You can have a look in the source code of this demo project. And we also seen an example of data analysis with OpenAI and Synapse. So I just want to thank you for listening, for staying with me today. This is my how to reach me, and go and drop and get the bits from GitHub. And if you have any questions, feel free to get in touch. And let's see if we have any questions from the audience. If you can talk about connection to external web API, would be great. Well, connection to external API works exactly the same way as what we've seen so far, right? So it's just instead of calling an external web API, I'm just using a function to make the HTTP call. I don't think there are other questions, Rav.
Yeah, there's no more questions, Marco.
Okay, fantastic. So thank you so much for having me. I hope you enjoyed the talk. And if you have questions, again, get in touch, no worries.
Well, thank you very much. And thank you, everyone, for joining.